Next question. Make an analysis of risk and return of two securities has return and risk different as under. Returns information have been given for X and Y. Standard deviation is given for X and Y. Recalculate the expected portfolio return and standard deviation for different values of X and Y, assuming R is equal to 0. Plot the different combinations of expected return and standard deviation with 10% change in the weight. Repeat the problem for R is equal to 1 and R is equal to negative 1. That is the question. Please go through the question, all of you. Let us have understanding of this question. Everybody is requested to pay attention. Let me give explanation to you first of all. The question says that you are required to take the different weights, that is, it is going to change by 10%. So different weights will be like this. Suppose you have invested fully in security Y, then 10% in X and 90% in Y, 20% in X and 80% in Y, and so on. The last portfolio will be fully in X and nothing in Y, 10% in X and 90%, 10% in Y and 90% in X. Then this is 80% and this is 20%. And so on. Like that, so we are required to make the computation of the return and the risk for the different portfolios like this. Now, as per the given information, as far as the security Y is concerned, its return is 21%. So, if at all you invest fully in security Y, then in that case, return of your portfolio will be 21%, and for security X, the return is 15%. So, if at all you invest only in security X, then in that case, the return is going to be 15%. That is what we understand. Now, if at all you invest only in one security, then in that case, whatever is the standard deviation of that security itself is standard deviation of your portfolio. Means, so the standard deviation of your security will be 28% if at all you make investment only in security Y, and standard deviation of security X will be 18% if at all you invest only in security X. That is what we understand. Standard deviation of security X is 18.6. So this is 18.6%. So this is 18.6, 18.6 and 18.6. And it has a return of 21%. Return of 15% mentioned over here. And if at all you invest in Y, return is 21 and standard deviation is 28. This is 21 and so the standard deviation is 28%. This is what we understand. Now proceeding further. Dear students, we understand that the return of the portfolio is simple weighted average. So if at all you invest 90% in Y and 10% in X, then what will happen, dear students? 21 into 0.90 plus 15 into 0.10. So 21 into 0.9, that comes to 18.9, plus 15 into 0.1, that comes to 1.5. So the total of both of them comes to 20.4. So this will be 20.4%. For this, we understand that say 80% investment is made in Y, which has a return of 21%, and 15% into 0.2. So 0.8 into 21, 16.8 plus 3, That comes to 19.8. So this is 19.8. In a way, friends, what will happen? You can understand very well over here that say between these two, so there is a change by 0.6 percentage. Again, between these two, so there is a change by 0.6 percentage. In a way, that's the return will reduce say by 0.6 percentage every time when you change from y to x. Why? Because the return of the portfolio is always simple weighted average. So over here it will be 15.6. Over here it will be say 16.2 and so on. Now friends, importantly, when correlation coefficient is positive 1, then in that case, so the standard deviation of the portfolio can be calculated by using the simple weighted average formula. That is what we have understood. We have seen an example like this. When correlation coefficient is positive 1, then in that case we can compute the standard deviation of the portfolio using the simple weighted average formula. So what will happen, dear students? Understand it carefully. So for this that is a making explanation. 28% into 0.90 plus 18.6 into 0.10. Okay. So 28 into 0.9 m plus 18.6 into zero point 0.1 again m plus. The total risk of the portfolio will be 27.06. Next, 28 into zero point 0.8 plus 18.6 into zero point 0.2. 28 into zero point 0.8 m plus 18.6 into zero point 0.2 again m plus. Memory recall, it is 26.12. So now what you can see, friends, 28 minus 27.06. Risk of the portfolio reduces by 0.94 percentage. 27.06 minus 0.94, and you can see this 26.12. Like that, so the risk of the portfolio will reduce say proportionately. Why? Because the correlation coefficient is positive 1. So 18.6 plus 0.94, this will be 19.54 plus 0.94, that comes to 20.58, and so on. We will have say the standard deviation. Now friends, what will happen when r is equal to 0 and when r is equal to negative 1? Then in that case we will not have the simple weighted average. Why? Because in that case we are required to form the formula, and so we are required to make the computation of the standard deviation. That is what we understand. I have provided answer for this to you. Now I want you to focus on something like this. Column number 1 is the weight of x. Column number 2 is weight of y. So this is the wx and this is w1. You may write along with all these things. Return of the portfolio is simple weighted average, and you can see it reduces at a constant rate 0.60, 0.60, 0.60, 0.60 and so on. Till this point of time it reduces by 0.60. This is what we understand. Correlation coefficient is 1. Then in that case the risk will also reduce proportionately by 0.94 percentage that we have seen. Over here say they have done some approximation. So you can see it reduces not exactly with the same, but if at all you make the detailed calculation, it will exactly reduce by that rate. So it is 1% or 0.9 percentage. That is the way say it reduces, and it goes down say to 0.186. In case of r is 0 or r is negative 1, it is not like this. Okay, this is what say I have explained to you so far. Okay, the next point that I want to explain you is this. Listen me carefully. I am taking randomly say a portfolio like this. What happens at say If at all the R is 1, then in that case the standard deviation of the portfolio is 25.2 percentage. R reduces to 0, then in that case the risk also reduces. R is negative 1, then in that case the risk further reduces. You can see that so the return of the portfolio is remaining unaffected. You take some other value. Let us take this value. In that case, again what you will see that say with the reduction in R, risk reduces. That is, the return of the portfolio is going to remain same. Again, we understand that say you take any other value also over here. Risk reduces. However, so the return of the portfolio is remaining same. And this is what we understand is basically say the effect of R. That is, say with the reduction in the correlation coefficient, the standard deviation of the portfolio is going to reduce. Now the next point that I want to explain you something is say something like this. Listen me carefully. What we understand over here, when R is negative 1, then in that case there is a possibility a portfolio will have 0 standard deviation. Yes. And coincidentally over here, we can see it is say 0.6 and 0.4. At that point of time, so the standard deviation of the portfolio is 0. This is what you can see. If at all you make the computation of the Wx, that is variance of y, so it is square of 28 minus 1 into what is standard deviation of x, it is 18, into standard deviation of y is 28, whole divided by variance of x, that is say square of 18, plus variance of y is square of 28, minus 2 into negative 1 into 18 into 28. So you can use your calculator. 18 into 28 into 2, that comes to 1008, and this will become positive. Square of 18 is 324. Square of 28 is 784. The value of the numerator is square of 28, 784, plus 18 into 28, that comes to 504. 324 plus 784 plus 1008, that comes to 2116. 784 plus 504, that comes to 1228, divided by 2116, that comes to 0.6087. So you can see it is 0.60. At that point of time, it is the least risk. You can see that if at all you deviate from that, in either of the case, risk increases. This is what we understand. When R is 0, at that point of time, we understand that so this is the minimum variance portfolio. Yes, this is what we understand is the minimum variance portfolio. At that point of time, we have the least risk. If at all you deviate from that proportion, then in that case, so the risk is bound to increase, whether you increase the proportion of x or you decrease the proportion of x, in either of the case. That is what we understand. You can see it is a straight line over here. Why? Because so the risk will change proportionately if at all the correlation coefficient is positive one. That is what we understand over here. This is what a small question, just to give you explanation, that say what is the effect of R. We do not have to do answer, we just have to understand say the different kind of return and risk that we will have say for the portfolios.